Have you ever laid back on a cool, clear night and just looked up? Looked past the streetlights, past the silhouette of the trees, and into the deep, dark velvet of the night sky. And as your eyes adjust, they appear. First one, then another, then countless tiny pinpricks of light, scattered across the immense darkness like spilled salt on a black tablecloth. They're the stars, and as you watch them, you might notice something curious. They are not still. They flicker, they shimmer, they seem to pulse with a life of their own. They twinkle. It's a gentle, quiet dance, a silent flickering that has captivated stargazers for all of human history. We write poems about it, we sing songs about it. A twinkling star is a symbol of magic, of wishes, of distant wonder. But have you ever wondered, in the quiet moments before sleep, what is really happening up there? Why do those distant suns seem to dance just for you? The secret, the reason for this beautiful, silent show, is not a story about the star itself. The star is not the dancer. The story is about the light's incredible journey. A journey that is billions upon billions of miles long. A journey that takes years, or centuries, or even millennia to complete. And the final, fleeting moments of that journey are what we see as a twinkle. So tonight, as you settle in, as you let your body grow heavy and your mind grow quiet, let's travel with a single ray of light. We will follow it from its fiery birth, across the vast and silent emptiness of space, and down through the final, invisible ocean that separates it from you. Let your eyes close if they feel heavy. You don't need to see this journey. You only need to imagine it. Let the world outside fade away, and let's begin our journey with a single, distant star. Far away, so far that our minds can barely grasp the distance, is a star. It is immense, a colossal sphere of incandescent gas, a self-contained furnace burning in the vacuum of space. It is not small, and it is not flickering. From up close, if we could withstand its power, we would see a thing of magnificent, unwavering stability. Its light is born deep within its core, in a place of unimaginable pressure and heat. Here, atoms of hydrogen, the simplest and most abundant element in the universe, are crushed together by the star's immense gravity. They fuse, they merge, and in that cosmic alchemy, they become helium. And in that moment of transformation, a tiny burst of pure energy is released. A particle of light, a photon. This is the beginning of our story. This single, tiny packet of light begins its journey. But it does not fly straight out of the star. For thousands, even hundreds of thousands of years, it is trapped within the star's dense interior. It is a world of thick, glowing plasma. Our photon is born, and it travels only a tiny distance before it is absorbed by an atom, then re-emitted in a random direction. It is a slow, staggering dance, a pinball game on a cosmic scale, taking place deep inside the heart of the star. For an age that is longer than all of recorded human history, our light particle zigzags, ricochets, and wanders slowly, patiently, making its way outward from the core. It is a journey of incredible patience, a testament to the slow, grand timescale of the cosmos. Through all this time, the star itself remains a beacon of constancy. Its energy output is a smooth, steady hum, not a frantic flicker. The fusion in its core is a continuous, stable process, like the deep, slow breathing of a sleeping giant. The light that is generated, the endless stream of photons, flows from it in a perfectly steady, unwavering river. There is no twinkling here. There is only a powerful, constant, and brilliant shine. Finally, after its long wandering, our photon, our single particle of light, reaches the star's surface. The photosphere. Here it is at last free. With nothing more to block its path, it bursts forth and begins its true journey across the cosmos. It leaves the surface of its parent star and shoots out into the great, open void. It travels in a perfectly straight line, a tiny, determined messenger carrying the story of its creation. It travels at the ultimate speed limit of the universe, the speed of light. fast enough to circle the Earth more than 7 times in a single second. Yet, the distances it must now cross are so immense that its incredible speed seems almost like a crawl. Imagine our photon now, a single perfect point of light, leaving its home star. It joins an infinite, parallel stream of other photons, all pouring out from the star in every direction. They form a sphere of light that expands outward, a silent, growing bubble of information and energy. Our photon is on a very specific path, a path aimed by pure chance, directly at a tiny blue and white planet, orbiting a yellow star in a distant spiral arm of a galaxy, a planet called Earth, but does not know this. It simply travels. For the first part of its journey, it moves through the near vacuum of interstellar space. The emptiness here is more profound than anything we can experience on Earth. It is a silence that is absolute. There is no air to carry sound, no medium to disturb. There is only the faintest whisper of stray atoms, 1 or 2 per cubic centimeter, not nearly enough to block its path. Our photon flies on, unwavering. Its line is true. For years it travels. Decades, centuries. The star it came from shrinks behind it, from a brilliant sun to a bright star, and then to just another point of light, indistinguishable from the countless others. As it travels, it may pass through wonders we can only dream of. It might glide through the edge of a vast nebula, a stellar nursery where new stars are being born. It would see these clouds of dust and gas, not as we see them in photographs, but as ghostly, faintly glowing veils. The light would pass through the thin gas, undisturbed, its path unchanged. The nebula is a silent, slow-motion ballet of cosmic creation, and our photon is just a silent observer passing through. It continues on its perfectly straight path. It is a constant, a single, unbroken thread of light. Think of it like a laser beam, but one that is infinitely long and perfectly steady. It does not waver. It does not flicker. The emptiness of space is a perfect medium for it. It preserves the light's integrity. The journey is lonely, but it is peaceful. There is no turbulence here, no storms, no weather. Only the patient, endless transit through the dark. For 1,000 years it travels, and then 1,000 more. The constellations from its home system would have long ago distorted and vanished. The universe it sees is completely alien to the one it left. It is a traveler in time as well as space. By the time it reaches its destination, the star it came from will have aged by thousands of years. The light we see in our sky is a ghost, a message from the past, a steady, perfect message. Our photon continues its flight. It might pass near another star system. From a safe distance, it would witness planets orbiting their own sun, but it would not be pulled in. Its path is a straight line, governed by the geometry of space-time. It bends only for the most massive of objects like entire galaxies, and even then, the bend is subtle, a graceful, cosmic curve over millions of light years, not a flicker. It is an arrow shot from a bow an eon ago, and its aim is still true. The light is still constant. The source of the light is constant, and its journey through the void is constant. There is still no twinkle. The light is pure, a direct communication from its star. It carries information about the star's temperature, its composition, its age, all encoded in its frequency and energy. But for our story, the most important piece of information it carries is its steadiness. It is a baseline of perfect, uninterrupted light. It is the control in our experiment. After a journey so long, it is nearly impossible to comprehend. A journey through silent, empty, and majestic space, our photon is nearing its destination. Ahead of it, a small solar system comes into view. It passes the orbits of giant gas planets, worlds with their own faint light, reflected from their central star. It crosses the orbits of rocky, barren worlds, and then it approaches a small, jewel-like planet, wrapped in a thin, shimmering blanket of blue and white. Earth. This is its final destination. After thousands of years of traveling in a straight, unwavering line, our photon is about to encounter the very last and most chaotic 100 miles of its journey. It is about to plunge into Earth's atmosphere. And it is here, in this final, invisible veil, that the dance begins. Imagine our atmosphere not as empty air, but as an ocean. A deep, deep ocean of gas, hundreds of miles deep, that we live at the bottom of. Like any ocean, it is not still. It is in constant motion. It has currents and eddies and waves. It has layers of different temperatures and different densities. This is the medium that our steady, perfect ray of starlight must now pass through to reach our eyes. Our photon, which has traveled for millennia in a perfect straight line, now hits the outermost layer of this ocean of air, the exosphere. This layer is incredibly thin, the transition into the vacuum of space. It is a gentle, almost imperceptible change. A few stray molecules of hydrogen and helium drift here. Our light particle passes through them without any noticeable effect. It is like the first, faintest touch of water on a ship that has been at sea for a lifetime. The journey continues downward. Next, it enters the thermosphere. This layer is much thicker, but the air is still incredibly thin by our standards. This is where space shuttles use to orbit and where the International Space Station glides on its silent path. It is a region of high energy, where the sun's radiation excites the few gas molecules that are there, raising the temperature to incredible levels. But there are so few molecules that it wouldn't feel hot. It is a strange, paradoxical place. Here, our photon might encounter its first tiny disturbance. A single, energized atom of oxygen might cause the tiniest, most infinitesimal deviation in its path. But it is not enough to be noticed. The light continues its plunge, still essentially straight, still essentially steady. It descends further into the mesosphere. The air is becoming denser now. This is the layer where meteors, shooting stars, burn up. They blaze across the sky in a fiery streak because they are finally encountering enough air molecules to create immense friction and heat. Our photon, being massless, does not burn up. It simply passes through. But the increasing density of the air is starting to have an effect. The medium is changing. The light, which has been traveling through a near-perfect vacuum, is now moving into a thicker substance. And light, when it passes from one substance to another, does something interesting. It bends. This phenomenon is called refraction. You have seen it many times in your own life. Think of a straw in a glass of water. When a straw enters the water, it seems to bend or break. Or think of looking at a pebble at the bottom of a clear, flowing stream. The pebble seems to shimmer and dance, to move from side to side. The pebble isn't moving. The water, a different medium than the air, is bending the light that travels from the pebble to your eye. And because the water is flowing and swirling, the light is bent in constantly changing ways, making the pebble appear to dance. Our atmosphere does the exact same thing to starlight. It is our planet's own flowing, invisible stream. Our photon continues its descent, entering the stratosphere. Here the air is calmer. This is the layer that contains the ozone layer, which absorbs harmful ultraviolet radiation from the sun, protecting life below. The air in the stratosphere is very stable, often layered by temperature, with cooler air at the bottom and warmer air above. There are fewer currents and less turbulence here. So, as our light particle passes through this layer, it is bent, but it is bent in a relatively consistent way. The entire column of light from the star is shifted slightly, but it is not yet broken up or made to flicker. The path is still mostly true, just gently curved by the overall density of the air is passing through. The real show begins in the final, lowest, and densest layer of the atmosphere, the troposphere. This is the layer where we live. It is where all of our weather happens. It's where clouds form, where winds blow, where rain falls. It extends from the ground up to about 10 miles. And this layer, this thin skin on our planet, is an absolute chaos of moving air. During the day, the sun heats the ground. The ground, in turn, warms the air just above it. This warm air is less dense than the cooler air above it, so it rises. As it rises, it cools and sinks again. This constant churning, this circulation creates pockets and bubbles and rivers of air, all with slightly different temperatures and therefore slightly different densities. Our atmosphere, especially the troposphere, is not a uniform, still pool. It is a roiling, invisible soup of temperature variations. It is a turbulent, flowing river. Now, our single, perfect photon, our unwavering messenger from a distant star, plunges into this troposphere. It has traveled for perhaps 5,000 years in a perfectly straight line. And in the last 1/100th of a second of its journey, everything changes. It hits a pocket of cool, dense air. As it passes from the slightly less dense air above into this cooler, denser pocket, it bends. Its path is deflected by a tiny, tiny fraction of a degree. A moment later, it passes out of that cool pocket and into a rising current of warmer, less dense air. As it crosses this boundary, it bends again. It is like our pebble in the stream. The starlight is the light from the pebble, and these pockets of warm and cool air are the swirling eddies in the water. For the last 10 miles of its journey, our photon is no longer traveling in a straight line. It is on a frantic, zigzagging path. It is jostled and bumped and nudged, first one way, then another. It is a chaotic, random dance dictated by the invisible currents of the air. A little nudge to the left from a cool parcel of air. A little nudge to the right from a warm bubble. Down, then up. The single, perfect ray of light has been shattered into a dancing, shimmering thread. And where are you in this story? You are at the end of the journey. You are lying on the ground, looking up. Your eye, specifically your pupil, is the final target. Your pupil is only a few millimeters across. It is a tiny, tiny window out of the entire sky. You are collecting light that enters that minuscule opening. The star is so far away that it appears as a single point of light. All of its light arrives in a column so narrow that it is essentially a single ray. And this ray is now dancing wildly just above your head. For a fraction of a second, the zigzagging path of the light happens to bend directly into your pupil. In that instant, you see the star as a bright point of light. But a millisecond later, a gust of wind, a thermal current, shifts the pocket of air a few feet above you. The light ray is bent just slightly away from your pupil. For that millisecond, the light from the star misses your eye entirely. And what do you perceive? The star seems to dim, or even disappear for an instant. Then, another millisecond later, another shift in the air bends the light back into your eye. The star reappears, bright and clear. This happens hundreds of times every second. The light is rapidly bending into your eye, then away, then back and again. Bright, dim, bright, dim. Your brain interprets this rapid change in brightness as a flicker, a shimmer, a twinkle. The star is dancing. But it's not just the brightness that changes. The bending of the light can also slightly change its color. As the light is refracted, it is spread out slightly into its component colors like a very weak prism. For a fleeting moment, the blue part of the light might be bent more directly into your eye, and the star will flash with a hint of blue. Then, a moment later, the red part of the spectrum might be favored, and you'll see a flash of red. This is why very bright stars, especially when they are low in the sky, can seem to flash with different colors. It's not the star changing color. It's our atmosphere acting like a chaotic, swirling prism, breaking the steady white light into its constituent parts and sending them dancing towards your eye. The twinkle is a beautiful illusion. It is the story of the light's final, frantic struggle through our restless ocean of air. The star itself, trillions of miles away, knows nothing of this dance. It continues to pour out its light with magnificent, unwavering constancy. The twinkle is a local phenomenon. It is a connection between you, the air you are breathing, and that distant, ancient sun. It is a reminder that you are looking up through a deep, living, moving medium. You might have noticed that planets don't seem to twinkle in the same way. You can often spot planets like Jupiter, Saturn, or Venus in the night sky. They appear as very bright, steady points of light. Why is this? Why do they get a pass from the atmosphere's dance? The reason is also about distance. Planets, while still very far away, are immensely closer to us than the stars are. Because they are closer, they don't appear as a single, perfect point of light. Through a telescope, you can see that they are disks. Even to our naked eye, they are not a true point source. They have a tiny but measurable angular size. You can think of a planet's light not as one single ray, but as a bundle of many, many rays of light, all traveling from different points on the planet's visible disk. Each one of those individual rays of light is, of course, being bent and jostled by the atmosphere, just like the starlight. Each one is twinkling. However, you're seeing all of them at once. At any given moment, some rays from the planet's disk are being bent away from your eye, while others are being bent into your eye. The effects average out. For every ray that is dimmed, another is brightened. The total amount of light that reaches your eye from the planet's disk stays almost perfectly constant. It's like looking at a large frosted light bulb instead of a tiny, bare filament. The large bulb's light seems steady, even if the individual points on its surface are fluctuating. So, the steady, serene light of a planet is a testament to its relative closeness, a neighbor in our own cosmic backyard. The frantic, beautiful twinkle of a star is a testament to its almost unimaginable distance, a visitor from the deep, deep cosmos. There's another place where you can see this effect even more dramatically. Look for stars that are very close to the horizon. You will notice that they twinkle much more wildly, more frenetically than the stars directly overhead. They might even seem to flash and change colors quite dramatically. This is because when you look towards the horizon, you're looking through a much thicker slice of the atmosphere. The light from a star directly overhead travels through the thinnest possible path of air to reach you. But the light from a star near the horizon has to travel diagonally through the atmosphere, a path that can be many times longer and passes through the densest, most turbulent air near the ground. It is like looking at your pebble in the stream through a much deeper, faster flowing part of the water. There are more currents, more eddies, more temperature pockets to pass through, more opportunities for the light to be bent and scattered. The dance becomes more frantic, the twinkle more pronounced. The star's light is being put through an atmospheric obstacle course, and the result is a beautiful, dazzling display of shimmering light and color, just for you, the observer at the end of the line. And what if you could leave this ocean of air behind? What if you could travel up past the troposphere, past the stratosphere, and into the silent vacuum of space? Astronauts aboard the International Space Station see a very different sky. For them, looking out of the cupola window, the stars do not twinkle. They are sharp, steady, unwavering points of light. They are intense and brilliant, set against a blackness that is deeper and more absolute than any night sky seen from the ground. They are seeing the stars as they truly are, before their light begins the final, chaotic dance through our atmosphere. Telescopes in orbit, like the Hubble Space Telescope, were placed there for this very reason, to get above the blurring, distorting effects of the atmosphere, to capture the clear, steady light from distant galaxies and stars, allowing them to see the universe with perfect, crisp clarity. The twinkle, as beautiful as it is a form of atmospheric noise that astronomers on the ground have to contend with. But for us here, lying comfortably and listening to this story, it is not noise. It is poetry. So now, as you lie here with your eyes gently closed, picture that journey one last time. Picture the light, born in the heart of a star countless years ago. Picture its long, patient, and unwavering journey through the silent, empty void of space. A perfect, straight line of energy, a message from past. And then picture the final moments. The plunge into our world's invisible ocean of air. The gentle currents, the rising bubbles of warm air, the sinking rivers of cool air. And see that perfect, steady ray of light begin to dance. A zigzag, a shimmer, a frantic, beautiful ballet in the final few miles of its epic journey. And that dance, That twinkle is delivered to your eye, a story whispered across light years and translated by the air you breathe. The very air that is filling your lungs right now, slowly and deeply, is the same air that is making the stars dance. With every gentle breath you take, the currents shift and the patterns of the starlight change. You are connected to this cosmic show in the most intimate way. The twinkle is a story about distance and closeness, the immense distance of the star and the intimate closeness of our own atmosphere. It's a story of constancy and chaos, the star's unwavering light and the atmosphere's restless motion. Let your breathing be slow and steady, like the constant light of the star before it reaches our world. A deep, slow inhale and a long, gentle exhale, and imagine that with every breath, you are stirring the currents of this great ocean of air. You are part of the system that creates this beauty. The twinkling you see is unique to you, in your exact spot, at this exact moment. The person next to you is seeing a slightly different dance because the light is passing through a slightly different column of air to reach their eyes. It is a personal performance delivered across the cosmos, just for you. Think of the starlight as a gentle, shimmering rain, a silent, weightless rain of photons that has been falling for eons. And our atmosphere is the wind that scatters the raindrops, making them dance and shimmer just before they land. It's a gentle, peaceful thought. The universe is not just static and empty. It is full of these quiet, beautiful interactions. The light travels so far, so patiently, and then in its very last moment, it puts on this special show. It is a finale, a celebration of its arrival, and then its journey is over. The photon is absorbed by a cell in your retina, its energy delivered, its message received. And another photon from the same star, which has been traveling right behind it for thousands of years, begins its own dance. As you drift now, let the idea of the twinkle be a soothing one. It is not a sign of turmoil in the heavens, but a sign of life on our own planet, a sign of the air that protects us, the air that we breathe. It is a gentle reminder of the invisible world that surrounds us, the currents and flows that are always in motion. Let the twinkling stars be like tiny, distant campfires, seen through the shimmering heat rising on a cool night. They are cozy, they are comforting, they are a sign of a vast, but ultimately peaceful universe. And you are here, safe and sound, at the bottom of this beautiful, shimmering ocean of air. There is nothing you need to do. There is nothing you need to figure out. You can simply rest and let the cosmos perform its silent, gentle dance for you. The stars will continue to shine steadily, and our atmosphere will continue to make them twinkle, long after you have drifted off into a deep and peaceful sleep. Let the rhythm of the twinkling be a lullaby, bright and dim, a soft, slow pulse to guide you into your dreams. The story is told. The light has arrived. Its journey is complete. And now, your own journey into rest can begin. Let go of the day. Let go of your thoughts. And just float here in the quiet darkness under a sky of dancing stars. The vastness of the journey is something to hold onto gently. For so long, our photon of light knew only the straight path. It was a singular purpose, an unwavering line drawn across the fabric of space-time. Imagine the patience of that light. It did not hurry. It could not. It simply was, and it moved. It passed through epochs. While it traveled, empires rose and fell on the tiny blue planet it was heading towards. Languages were born and died. Entire species evolved and vanished. And through all of it, the light just kept coming. A steady, reliable messenger. It is a comforting thought, this constancy, that in a universe that can seem so chaotic, there are these fundamental, dependable processes. The star burns steadily. The light travels faithfully. Its message is one of endurance. When you look at a twinkling star, you are not just seeing a point of light. You are seeing the culmination of a journey that is almost eternal from a human perspective. You are seeing time itself. The light from the nearest star, Proxima Centauri, takes over 4 years to reach us. The light from Polaris, the North Star, has been traveling for over 400 years. When you see it twinkle, you are seeing light that left its star when Galileo was just beginning to question the heavens, when Shakespeare was writing his plays. The light from stars in the Andromeda Galaxy, the most distant object visible to the naked eye, has been on its journey for 2.5 million years. And through all that time, through all that distance, it held its course, a steady beam, only to be made to dance in the very last fraction of a second by the gentle, restless air of our own world. This dance, this scintillation, is a form of welcome. The universe is vast and cold and largely empty. But here on Earth, there is this blanket of warmth and air and life. Our atmosphere is a sign that this place is different, and it greets the ancient light from distant suns by making it shimmer. It's as if the air itself is excited by the arrival of this long-distance traveler, and it has to give it one last, joyful little shake before it completes its journey. So, when you feel a gentle breeze on your skin, you can remember that this same motion, happening high above you, is what is orchestrating the light show in the night sky. The air that caresses your face is part of the same system that caresses the starlight. It connects you directly to the cosmos. You are breathing the very medium that makes the universe sparkle. As you sink deeper into comfort and rest, let this connection be a source of peace. You are not separate from the universe you observe. You are a part of its workings. Your breath is a tiny current in the great ocean of air. Your eyes are the final harbor for light that has crossed oceans of space. Let's think again about that pebble in the stream. It's such a simple, earthy analogy for such a grand cosmic process. You can picture it clearly. The smooth, gray stone sitting on the sandy bottom, the clear water flowing over it, the way the sunlight dapples on the water's surface, and how that dappled light makes the pebble seem to wiggle and warp. The motion of the water is the key. If the stream were a perfectly still, frozen sheet of ice, the pebble would look perfectly still. The twinkling of a star is proof that our atmosphere is not frozen. It is alive. It is a fluid, dynamic thing constantly in motion. It flows and churns in ways we can't see, but the starlight reveals its hidden dance. The stars become tiny probes, sending their steady beams down to us. And those beams report back on the state of the air they had just passed through. A frantic twinkle means a turbulent patch of air. A gentle shimmer means the air is calm. It is a weather report written in light from 10 miles above our heads. And so, the night sky is not a static painting. It is a living canvas. The stars provide the steady points of light, and our atmosphere paints the shimmering, dancing motion over them. It's a collaboration between the distant and the near, the ancient and the immediate. And you are the audience. You are the one for whom the show is performed. As you lie here, letting go, allow your mind to appreciate this quiet, constant performance. There is no need to applaud, no need to even stay awake for the whole show. The show will go on. The stars will burn. The light will travel. The air will dance. It is a perpetual motion machine of beauty. You can simply relax and trust that it will be there. Trust that this gentle, cosmic process is unfolding above you, a silent lullaby of light and air. Allow the thought of that steady, unwavering light to calm your mind. For thousands of years, a straight line, patient, calm, determined. Let your own mind find that same sense of quiet purpose as it prepares for rest. Let go of the zigzags of your day, the chaotic thoughts and worries, and for a little while, find that straight, calm path towards sleep. The twinkle is a story written in a language of light, translated by the air and read by your eyes. It's a story that says, I have traveled far, I have been constant, and now, at the end of my journey, I will dance for you to show you the life and motion of your own world. It's a beautiful, humble ending to an epic journey. And now, it is time for your own journey of the night to begin. A journey into the quiet, restorative world of sleep. Let the dancing stars be the last gentle thought you hold. A soft, shimmering, fading image. Let them dance you into your dreams. The air is calm. The night is deep, and you are ready for rest. The universe will keep its watch. The stars will keep their vigil, their light traveling, always traveling, to greet you again tomorrow night with their familiar, gentle twinkle. Sleep now. Rest deeply. The story of the stars is a story of peace, and it is now your story too. Let's linger for a moment on the scale of it all. The star, a furnace of such magnitude, burning with a light so constant. The photons pouring from it, an endless river of energy flowing out into the blackness. An act of creation that is continuous, happening right now, trillions of miles away. That light, our photon, begins its journey. Imagine it as a tiny golden speck. It leaves its home, a place of unimaginable heat and fury, and enters a realm of unimaginable cold and quiet. For so long, it travels. The silence of deep space is not an empty silence. It is a silence full of presence, the presence of immense distance and time. Our golden speck of light passes through this silence. It is a pilgrim on a sacred journey. It carries a memory of its creation, a spark of the fire from its parent star. It is a tiny piece of a distant sun, sent out to explore the cosmos. As it flies, the galaxy around it wheels in a slow, majestic pirouette that takes hundreds of millions of years to complete. Our photon, in its few thousand years of travel, only sees a tiny fraction of this grand movement. It is like watching a mountain move for only a single second. To the photon, the universe it travels through is a static, frozen sculpture of light and shadow. The nebulae it passes are motionless clouds. The distant galaxies are frozen swirls of light. Its own speed is so great that the universe outside its path seems held in a state of suspended animation. Its path remains true, a straight line. Think of a thread being pulled from a spool. The spool is the star, and the thread is the ray of light. It unspools into the darkness, a perfect, unbroken filament. This perfect thread travels for an age. It is a carrier of pure information. And then it arrives. It smells, in a way, the change ahead. The faint, outermost traces of a planet's breath. The exosphere. The water is shallow here, in our ocean of air. The first few molecules it meets do not disturb its path. It is like a ship entering the calm, shallow waters of a vast bay, after crossing a great ocean. The waves are small, the disturbance minimal. The light continues its descent, down, into the deeper waters of the thermosphere and mesosphere. The medium around it is thickening. The water is getting deeper. And our photon, our perfect thread of light, begins to feel the drag, the pressure of this new environment. It begins to bend. The straight line begins to acquire a gentle, subtle curve, dictated by the overall density of the atmospheric sea it has entered. It is still a single, coherent thread. It has not yet begun to dance. It is just adjusting its course, accommodating the new reality of a denser medium. It is like a diver adjusting to the pressure as they descend. And then the troposphere, the final layer, the seabed where we live. This is not calm water. This is a churning, roiling place. It is a place of thermal currents, of invisible waves and whirlpools. It is the weather. Our perfect, single thread of light now enters this turbulence. And it is torn apart, not in a violent way, but in a playful way. It is stretched and bent and sent on a chaotic looping path. The single thread is now a dancing, shimmering ribbon. A pocket of cool air, denser than its surroundings, acts like a tiny, invisible magnifying glass. For a moment, it focuses the light, making it brighter. The ribbon glows. Then it passes into a pocket of warm, rising air, which is less dense. This pocket acts like a diverging lens, scattering the light, making it dimmer. The ribbon fades. Brighter, dimmer, brighter, dimmer. The ribbon of light is being played like an instrument by the atmosphere. Its brightness is the note, and the wind is the musician. And this music of light, this symphony of shimmer, is what finally arrives at your eye. Your tiny, waiting pupil, and your brain, the great interpreter, translates this rapid-fire sequence of bright, and dim into that one magical word, twinkle. It is a profound and beautiful thing. The light from a star is ancient and pure. It is a constant. In our atmosphere, a thing of chaos and life and constant change, takes that pure, constant thing and transforms it into something that looks alive. It imparts the chaos of life onto the sterile purity of the starlight. The twinkle is the signature of our living world, imprinted upon a message from the distant universe. It is a collaboration, a duet between a star and a planet, between the vacuum of space and the breath of life. It's a reminder that even the most constant things can be made to dance when they pass through a place that is full of life and energy. And you, the observer, are the one who gives this dance meaning. Without your eye to catch the flickering light, without your brain to interpret it, it would just be a random jiggling of a light ray. But you see it, and you call it beautiful. You give it a name. You write it into your stories and your songs. You make it a part of your human experience. So as you rest, feel the gentle weight of your own body, the warmth of your own breath. You're a creature of the troposphere. You belong to this churning, living layer of air. And the dancing of the stars in your sky is a reflection of the world you inhabit. It is the sky's way of saying, you are home. You are in a place of movement, of change, of life. Let that thought cradle you as you drift off. The universe is not just out there, separate and distant. It is right here. You are breathing it. You are seeing it. You are part of its dance. And now, it is time to rest and let the dance continue in your dreams.